This is a circle equations tutorial. The basic equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where h and k is the center of the circle with a radius of r. Remember that every circle has a center, and if you were to plot that circle on a coordinate plane, you could ascribe an x and y value to where the center is located. Well, when we're dealing with circles, we don't refer to the center as having an x and y value. We refer to it as having an h and k value. It'll be easiest if I just show you a practice problem and we work through it. So here's our practice problem. You can see the formula that we have on the left. Here's our equation for this particular circle that we're working with. The quantity x minus 2 squared plus y plus 1 squared is equal to 16. Now the first thing that we want to do is establish what our h and k values are. Now if you look at our equation of a circle, it's always x minus h squared and y minus k squared. So the h and k that you find in the actual problem of your circle, so this problem over here, the h and k values are always the opposite of what you see right here. So if you see a negative 2, that means that your h value is actually positive 2. Because it's supposed to be x minus h. H is the positive 2 right here, and it's x minus that h. So x minus that positive 2. And the same for our k value. Over here, we have y plus 1. Now the only way it could be y plus 1 is if k were equal to negative 1. Because our standard equation of a circle is y minus k. So it should have had a minus there unless that k was already a negative 1. Then the minus negative 1 would have become a positive 1. So it's easiest to just think of it that way, is that the h and the k value in your problem is always going to be the opposite of what it looks like. Now let's go ahead and solve for our radius in this circle. You'll notice in the standard equation of a circle that everything on the left there is equal to r squared, and r is our radius. So that means that this right here, 16, must be equal to our r squared. So if 16 is equal to r squared, we could solve for r, the radius of our circle, by just removing that square, and to do that we take the square root. The square root of 16 is 4, and the square root of r squared is just r. So our circle has a radius of 4. So now that you know the h and k, that's the center of where this circle occurs, and you know its radius, you're able to draw that circle on our graph. I'm going to go ahead and drop a point where the center is. Remember that h and k are corresponding to your x and y respectively. So this is our x value and this is our y value of the center. So our x is 2, so we'll go 2 to the right, and our y is negative 1. So the center of our circle is right there. Now we know it has a radius of 4. So that's the distance from the center of the circle to the outside edge of the circle. So you could go 4 units in any direction and drop a point. I'm going to go just your typical northeast, south, and west. I'll go straight up 4 units, 1, 2, 3, 4, and plot a point. Then I'll go to the right from the center 4 units, 1, 2, 3, 4, and plot a point. Then down from the center 4 units, 1, 2, 3, 4, and then to the left of the center 4 units. And I'll plot a point there as well. Now that you have those 4 points in the center plotted, you can go ahead and draw a circle around that center to connect those points. So the circle that we've drawn here is derived from that original equation, that problem you were given right here. Now let's take a look at a couple more examples of drawing circles from an equation, and they're going to get a little bit more complex. In this example, you're given the center of our circle, and you're given a point on the circle. What I'd like you to do is to actually write the equation for this circle. We don't need to graph it, I just want to know what the equation of this circle would be given the information that we have here. Let's start by determining the center of our circle, the values of our h and the value of our k. Well, that's automatically given to us because we know that h and k is the center of a circle. and we have the center right here. So this must be our h, and this must be our k. So I'll write those over here. H is negative 13, and k is negative 16. So what we can do is write the generic form of our equation right here. We have x minus our h, so minus a negative 13 squared, plus the quantity y minus our k, which is negative 16 squared. And that's going to be equal to our radius squared. And now we need to determine what our radius is. Well, to determine our radius, we can look at the point on the circle there. If our center is at negative 13, negative 16, and the circle point is at negative 10, negative 16, you'll notice that their y-coordinates are the same, negative 16. And the difference between their x-coordinates is 3. If you traveled from negative 13 along y equals negative 16, you'd have to go 3 units to the right to arrive at negative 10. So if you have to go 3 units from the center of a circle to the edge of a circle, then that circle has a radius of 3. So our radius over here is going to be equal to 3. I'll show you that on a graph. I'm going to go ahead and go by 2's on these units, and I'm going to go first to our center. So I'm going to go negative 13 to the left and then 16 down. I'll go ahead and plot a point here for our center. Now remember, a point on our circle was at negative 10, 16, so it's still down here at negative 16, but instead of being at negative 13 right here, it's going to go over 3 units to negative 10. And since we're going by 2's, going over 3 units would be right here. So you'll notice that this distance here is the radius of our circle, because our circle is just going to go around that center like that. And that distance there for our radius was 3 units. So now let's get back to writing our equation. We know that our radius is 3, but in our equation, they don't ask for your radius after the equal sign. They want your radius squared. So 3 squared is 9. Now I'll rewrite this, distributing those negatives as they should be. So x minus a negative 13 is actually x plus 13, quantity squared, plus y minus a negative 16. And minus a negative 16 is plus 16, quantity squared, is equal to 9. So that is how you would write the equation of this circle right here. Now let's take a look at another practice problem. In this problem, I've given you the center of our circle, and I've told you that it has an area of 25 pi. What I'd like you to do is write the equation of this circle and graph it. Let's begin with the equation of the circle. We know that since its center is at 0, 3, that must be its h, that's 0, and that must be the k value, 3. So h is equal to 0, and k is equal to 3. Now we also have the radius here, hidden inside this area. If the area of the circle is 25 pi, and you know that the formula for the area of a circle is equal to pi times radius squared, we can solve for that hidden radius. The area of our circle is 25 pi. So that'll be equal to pi times our circle's radius squared. I'll divide by pi on both sides of the equation. So we have 25 is equal to radius squared. Well, to solve for radius, we'll just take the square root of both sides of the equation. The square root of 25 is 5, and the square root of r squared is just r. So we have a radius of 5 units. So we can write our equation now. Our equation is x minus h, which in this case is 0, squared, plus y minus k squared, so y minus 3 squared, is equal to our radius squared, and our radius squared is 25, since our radius was 5. Now I'm going to rewrite this as you would most commonly see it. You don't normally see it x minus 0. There's nothing to put there since it's minus 0. So you just see it as x squared plus y minus 3 squared is equal to 25. So let's plot this circle now. We know that the center is at 0, 3. So we'll go from the origin up 3. And we'll plot our center. And we know that we solve for the radius, and it's 5. So you could go 5 in any direction and drop a point. So I'll go 5 up to 8. I'll go 5 to the right to 5. Then 5 to the left from the center to negative 5, all on that y equals 3 axis there. And then 5 down to negative 2. And I'll go ahead and draw on the circle for our graph. Alright, so these are some of the most common ways that you're going to be given a formula or a problem and asked to solve for the equation of a circle and then graph it.